Hello friends, welcome back and thank you so much. I'm always excited to do this with you. Now today I want us to look at how to find the inverse of a 2 by 2 matrix. For example, you could be given a matrix, say by name A is 4, 3, 2, 2 is an example of a 2 by 2 matrix. Then you are asked to find its inverse, written as A inverse. In this case, what we need to first of all do, there are 2 or 3 procedures that we need to follow, and the third procedure will actually be the desired outcome. So in this case, in the first place, first we need to find the determinant of the matrix. So short form written as det A. And the determinant of a 2 by 2 matrix is calculated by getting the product of the elements in the leading diagonal. The diagonal running from top left to bottom right is what we are calling the leading diagonal or the principal diagonal. So the product of the elements, like in this case, is 2 times 3, 2 times 4 or 4 times 2, which in this case is 8. And then less, we subtract the product of the elements in the other diagonal. This other diagonal is just referred to as the other. So we have 8, 2 times 3, which in that case will be 6. So the difference is 2. 2 is the determinant of matrix A. And then the second step is we interchange the positions of the elements in the leading diagonal. So in the leading diagonal, we have 4 and 2. So we interchange them. So where there's 4, we have our 2. And where there's 2, we have our 4. And then the elements, we reverse the signs of the elements in the other diagonal. So we don't interchange them, but we reverse their sign. So if in this case, they are both positive, this positive 3, this positive 2. So reversing the sign means, so we have negative 3 instead of 3 as it were. And then here we'll have negative 2. So that's what we have. Then the next thing, the third step, we multiply this new matrix formed in the second stage by the inverse of the determinant. And what does that mean? The inverse of the determinant is actually the reciprocal of the determinant. So that is 1 over 2. Now we multiply by this new formed matrix, 2, negative 3, negative 2, 4. Okay. And that gives us now the product of the inverse of the determinant and the new matrix formed is what is now referred to as the inverse of matrix A, which in this case now we can open the bracket, and opening this bracket or multiplying the inverse by the matrix involves multiplying each of the elements. These numbers found within a matrix are referred to as elements. So we multiply each of the elements by the reciprocal of the determinant. So in this case, we'll have 1, that is a half times 2, 1, a half times negative 3 is negative 1.5. Then a half times negative 2 is negative 1. And a half times 4 is 2. So what we have here is the inverse of matrix A that we had. So the first stage, find the determinant. Second step, interchange the elements in the leading diagonal and reverse the signs of the elements in the other diagonal like we have in this case. Then the third step is multiply the inverse of the determinant by the new formed matrix. The product is the inverse that is desired. Now this can be proved by multiplying the matrix and its inverse. So that is, if you multiply the matrix and its inverse, then you should be able to get an identity matrix which we call I2, and that is 1 0 0 1. And if you do that with this and the original matrix, this is what you will find. So if this was helpful, please give me a thumbs up and smash that subscribe button and the bell button so that in case I post any new videos, you'll be alerted. Thank you so much. See you later.